Alright, let's see what you came up with for example number 2. So first things first, let statements. We're going to say let the cost of a student ticket equal S, small s, I'll get to the variable. Let the cost of an adult ticket equal the variable A. Now we have defined each variable S and A. Okay, so let's see what the information says. One busload of 4 teachers and 34 students paid $428. So what's the equation that we can generate for that? Right, a busload of 4 teachers and 34 students paid $428. So 4a, I'm using small a, so I'll be consistent. So 4a plus 34s equals 428. Right? If there's 4 students and those students paid, 4 adults and those adults paid $4 per adult. $8 per adult, and there's 4 of them. So 4 times a. And there's 34 students and each student paid S dollars. So 34 times S. You add the total money up, you should add up to 428. That's bus number 1. From bus number 2, we get another equation. 3 teachers and 29 students paid $356. So what would the equation be this time? 3a plus 29s equals 356. Right? That's our equation. This is our system. We can also use guess and check to try and solve this equation, but it's probably not going to be the best strategy that we're going to need to use. So we're not going to solve them. Right now we're just setting them up. I'll show you later on how we can solve them. Okay, let's try another example here. So here's another example. Alright, let's have you guys try that first before I go over it. Okay, first things first, we set up our let statement. So I'm going to say let the number of pop cans collected equals C. I'll just pick a variable C for cans. And then I'll say let the number of plastic bottles collected equal B. I've used those parentheses just to kind of state that's the same thing as above. So that means let the number of plastic bottles collected equal B. Now because I'm working with dollars and cents, I'm going to convert everything into dollars. I'll make a note that 5 cents is equivalent to how many dollars? How do I write 5 cents into dollars? $0.05. Right? Similarly, I can write 20 cents as $0.20. Right? So I want to make sure that I'm in dollars throughout because my other number is dollars as well. So one of the statements I'm going to get is that $195 was raised by collecting 3,000 items. So I'm going to collect $195 from all the bottles and cans that I collect. So if C is the number of cans that I collected, so then 0.05 times C, so all the money I collected from the cans, plus 0.20B, all the money that I collected from the bottles, adds up to $195. Actually, I won't put the dollar sign, that's an equation. So that's going to be my first equation. If I'm getting paid 5 cents per can and 20 cents per bottle, then I'm going to take the number of cans, multiply by 5 cents, take the number of bottles, multiply by 20 cents, and that money's got to add up to 195. What's going to be the second equation? What would the second equation be? Total number of cans and bottles. How would you write an equation for that? AC plus DB. We're only using variables C and B, right? So I'm just going to say the number of cans represented by C, the number of bottles represented by B. So if I take the number of cans plus number of bottles, what do they need to add up to? 3,000. That's my second equation. Right? That's two equations that I generate from that. It didn't have to be two separate sentences. I got all that information off the single sentence. Right? $195 were raised by collecting 3,000 items. I just had to translate that into multiple equations. That made sense. Are we okay with that? Okay, now time to check and see if our solution works. So the school collected 2,700 pop cans and 300 plastic bottles. Use the linear system to verify these numbers. You want to make sure that the numbers make sense. So we're going to check each of those equations. So we're going to substitute C equals 2,700 and B equals 300 into our equations. So equation number 1, let's check that first. So check 1. 0.05 times 2,700 plus 0.20 times 300 has to equal 195. Okay, let's do a little bit of number crunching here. 2,700 times 0.05, what does that give you? 2,700 times 0.05. 135 plus 0.20 times 300, 60, has to equal 195. Which means 195 has to equal 195. Does that statement make sense? Yeah, so it's confirmed. Left hand side equals right hand side. Similarly, I can check equation number 2. Equation number 2 says C plus B has to equal 3,000. So that means 2,700 plus 300 has to equal 3,000. Which means 3,000 equals 3,000. Right? So that one's verified as well. So therefore, C equals 2,700, B equals 300 satisfies the system of equations. Alright, let's try another one. Example number 4. Give you a few minutes to try that one. See what you come up with now. Okay, let's see what example number 4 looks like. So, chub and smelt are each sold by the kilogram. Chub sells for $2.50 per kilogram and smelt sells for $1.50 per kilogram. The total cost of the order of some fish is $30. If 16 kilograms are bought in total, how much of each was bought? So the first thing that we're being asked is how much of each was bought. So we're going to set that as our let statement. So I'm going to say let the amount, and amount is in kilograms here, of chub bought equals C, and then let the amount of smelt bought equals S. So the first equation we're going to get, so what will be the first equation? We're given two pieces of information. First, we're told that 16 kilograms are bought in total. So what does that tell us? C plus S equals 16. Right? The amount of the two items bought added up together gives us 16. What else do we know? Jamila? That's right. C times 250 plus S times 150 equals $30. However, when I write that out, I always write coefficients first before the variable. The variable always goes second. So when I write that, I'll write it like this. I'll go 2.50 C plus 1.50 S has to equal $30. So $2.50 times the amount of C you bought plus $1.5 times the amount of S you bought. And the total money you paid was $30. Those are your two linear equations. Again, left hand side is dollars, right hand side is dollars, dollars and dollars. Add up. So far so good? Okay, we'll finish off with one last example over here on the other page. So this time we're sort of working backwards, well, kind of backwards, and we're looking at equations and trying to come up with the word problem that goes with it. So a store sells wheels for roller blades or roller skates in packages of 4 and wheels for inline skates in packages of 8. Create a situation about wheels that can be modeled by the linear system below. Explain the meaning of each variable. Write a related problem. So this time I've given you the variables and the equations. You want to create your own word problem. So I'll give you a few minutes to try and think of a word problem that matches up with that set of equations. Make sure it properly matches up. And then define what each variable is going to represent. So I'll give you a few minutes to think about that. Alright, so our system has two different equations. Equation number 1 and equation number 2. Can we make sense of any of those equations? Like, are there any numbers that kind of stand out and try and tell you something? You'll notice in equation number 1, the number 8 tells you something and the number 4 tells you something. What does the 8 tell you? Number of wheels in a package for inline skates and number of wheels in a packet for roller skates. Right, there's 8 wheels in an inline skate package and 4 wheels in a roller skate package, and that equation is probably telling you how many package of each you bought, right? So that way you multiply how many packages you bought by the number of wheels in each packet and you get the total number of wheels you bought. So I'll write that down. I'll say the variable I, so in equation 1, the variable I is multiplied by 8. Okay. Which is the number of inline skates in a package. Therefore, I represents the number of packages inline skates bought. Right, so if the 8 represents the wheels in inline skates package and you're multiplying it by I, then I must represent how many of those packages you bought. Similarly,